Thank you.
All right.
Sorry, I cannot see you. Good afternoon, ladies and gentlemen. Today, or this hands-on, is about how to run machine learning workloads on AWS in a streamlined way. And when I say that, I want to start with a real pragmatic use case. How many know Anthropic? Okay. How many know what kind of model they have? Few. So Anthropic is one of the top 3, depending on what week, what hour. And they have a real use case where they have a machine learning workflow, starting from training, going through data processing and stuff like this using Spark, ending with inference. And they needed a cost-optimized way to achieve all of this. And guess what? The 3 core components, S3, EKS with Karpenter to do cost-effective auto-scaling. They managed to save 60%. So they achieved 60% performance with cost saving of 40%. My name is Walid Al-Shari. I am with my colleague.
Ahmed Azzam, Senior Solution Architect, AWS. I'm working with startup team. Okay. So today our agenda is full of wonderful stories. So basically we'll focus on a new innovation in running machine learning infrastructure using Amazon EKS Auto Mode, a way to simplify operation while optimizing your performance. So we'll start by discuss machine learning problems from scaling down to managing resources and dependencies. And then we'll talk about, we'll unpack the benefits.
We are hands-on. It's about the journey, Azzam.
Let's go to the console. All right. Walid is very excited.
We need to get our hands on. This is about live coding.
Oh, sure. Okay.
So I'll play the role of platform engineer. Azzam is a data engineer who moved to business. Okay, and he will be giving me a hard time. This is a real use case that happened to us last week, by the way.
All right. So let me give you my requirement first, Walid. So today,
if you can zoom a little bit.
I can zoom a little bit. Okay. So
everybody sees, okay? Yeah.
All right. So basically today, I have 3 basic requirements. I want to run 3 different applications. Most of them they're using machine learning, and each application has different requirement from compute and type of nodes. And I want to run all of them on the same EKS cluster, same single control plane.
Why?
I'm looking for simplicity. I don't want to run multiple cluster, upgrading. Every time I have to manage like multiple clusters. I want to have single control plane.
So the message is ideation to proof of concept to production. And you want to save cost. You don't need different cluster when it comes to ideation, when it comes to proof of concept.
Okay, so what I want to build, I will show you now the end result, and then we'll go through step by step how to build this with hands-on. So first of all, I want to run a chatbot application using one of the Gen AIs. Here I picked DeepSeek distilled, and I'm using Web UI as an interface to build the front interface.
Which user interface you're using?
Web UI.
Okay, so basically we are using Open Web UI. You can create user interfaces using natural language, and it's Python. If you want to customize it, you can use Python. And this is one of 2 that we'll show you today.
Nice. And the other use case is a little bit more advanced. I want to run a Whisper model from OpenAI to do speech-to-text recognition. And I want to run it again as a web interface using Gradio.
OK. So we mentioned Gradio. We mentioned Open Web UI. Both are streamlined proof of concept user interfaces if you want to get your ideation fast to your customers, or you want to try to different models fast. So you can change from one model to another in minutes.
And the last one is just a simple game I want to play in between while we're doing the deployment. All right, I think we need to hold mode. OK.
So I go back?
All right.
You go back now? Oh, no, you do the compile, huh?
Yeah, no, you can show us what we have on the cluster.
You want to start the GPUs, huh?
Yeah. So let me.
3.
All right. Okay. So now let's see what we got here on the cluster. So we have different types of node pools.
Everybody knows EKS, knows Kubernetes? Yes? How many knows Kubernetes? Who doesn't know Kubernetes? You don't know? Okay. By the way, you can talk to us for a workshop for enablement after this. If anybody needs enablement, needs how to do it, talk to us. And you don't need to learn much about Kubernetes because we'll show you EKS Auto Mode, which is the managed Kubernetes in terms of control plane, in terms of data plane.
Amazing. So now should I open the new cluster so we can...
So what you see here, he's using an interface called K9s, which will show him the object. Kubernetes is all about resources, object. Each object is an ABI. Think of it as an ABI. The execution, the minimal execution object is a bot. For networking, you have a service, you have ingress. And why we use Kubernetes, we will tell you. But it's basically, think of it as an orchestration. And for machine learning workflow, you need orchestrations.
So the way it works here, we have 3 types of node pools. And actually, what I'm trying to do is to run different workload on different type of compute. So for example, for the Whisperer, I want to run it on AWS Neuron. And then for the other one, I want to run it on GPU on NVIDIA processors.
So basically, a node pool is just a bunch of things which are compute. This compute will have also storage. It could have very fast network using what we call EFA, our enhanced fabric adapter. And in training especially, you need the compute to be closest to each other. So you know that we have a service called AWS Ultra Cluster. So and that's where you drop resiliency. You want them to be in a single availability zone as fast as possible, as low latency as possible, and with the much throughput as possible. This is for training. But for inference, you need low latency. You need high number of requests. It could be distributed. So what he is doing now, he's starting one of the projects. Now, most likely, you say what he's doing. OK, so he cloned a repo. Using Terraform, he created the EKS Auto Mode infrastructure. You can create it from console. You can create it from Terraform. You can create it from CDK. It takes 10 to 15 minutes for the cluster to be up fully with day 2 operations. That is storage, network,
compute,
security, of course,
observability,
security out of the box from day 1. You don't need to think about it. It's from day 1. So day 2 capabilities from day 1.
OK, so what I'm trying to run now is, first thing, I need to run the container for VLLM to run the DeepSeek.
We need to go back to the...
I've already created the node pools.
OK.
OK. So now let me show you what does this...
Describe it.
Yeah.
So when you do apply command, it basically go through the manifest, which is YAML, which he didn't show us. He cheated. But he can display the YAML file. He can display the result of it using kube control describe, for example.
OK.
Show us the...
kube control.
Give me.
You want to describe
tell me
what do you want to do? Show us now the status of the deployment. What happens? Can you run kube get all?
So there is a concept of namespace. I have a service, but I don't have anything else. So I don't have bots. Did you really deploy? If I do kube KNS, which is a kube namespace, I can see that I am on the default. So basically, I'm in the wrong namespace. I should change to which namespace?
VLLM.
So basically, this is a common mistake, especially in live demos. It's OK. OK. It's not, so now I do get all again. We don't have anything. So this is another mistake. So did he deploy?
Yeah, I did a deployment, but it did not yet finish. I think it's created.
No, it should.
Can you show us kubectl get deployment?
You have nothing. What's the file? What's the?
Because you are on the default namespace. It's still in the default namespace.
No. If I do KNS.
Get -a.
No. Siri, we are not there yet. So if I do KNS to check which namespace I am on,
You're still on the default, Walid. You found the
so
same
this
mistake.
is my problem. Okay.
Okay.
Which one I go?
Yeah, to VLLM.
Okay, and I just
Okay.
double check this time. Okay.
Now you're good.
And now we do
Get bots, get deployment.
get deployments. Yes,
we have
a
one.
deployment.
See?
So if something is working, say Q. Yeah?
Okay.
Nothing. Okay, if I do kget bots, I see the bot is bending. Can you show us why? So
Would you like to
basically,
ask our friend?
the concept of a bending bot, that means it needs compute. But EKS Auto Mode uses Karpenter just on time scheduling, so it should have triggered a request for a compute from a selection. And this selection is the one that he defined in a node bool.
So I did kubectl describe.
ماشي عندنا وقت ولا عندنا وقت؟
No node yet.
Maybe you go to the live cluster.
Go to the live cluster. Okay.
Well, we got blacked.
Yeah. Okay. Okay, so let's see what we got here. Kubectl, get pod. All right. Okay. So yeah, in this cluster,
can you show us EKS node view?
Node viewer.
Yes. So the node viewer shows us basically the nodes, how much they are utilizing, and if you delete a pod, can you show us basically if you delete a pod in the instance or something?
Let's maybe delete the game.
Delete something small,
kubectl,
like Whisper Neuron.
Yeah, let's say kubectl get pod -a. Let's delete that one.
I bet that you are confused. You don't know what we are doing, but that's fine, because we lied. We said Walid and Ahmed will present, but we actually have another presenter. Do you want to change to the other presenter?
Yeah.
We have online presenter. Can you change, please, to the online presenter?
Of course. Let's ask him.
Yes.
Q.
Chime.
Okay. You want to show on a chime?
So the other presenter is Q.
Let me make it bigger.
I make it bigger from my side. So anybody using Q Developer CLI? So Q Developer CLI is a Gen AI assistant. And it's very fast developing. So every time you use it, start with Q update just in case. If you have a session from before, you can say Q chat, resume, so that basically your old context will be there. Okay? Now I will ask you to explore. Because I am a new employee, I want to explore. So basically, it resumed my session from before. I say explore and tell me more about any EKS cluster. So the beauty about Q, it keeps context, and you can create context specific for it, and you can connect it. Everybody knows what MCP is, Model Context Protocol. Okay, so Model Context Protocol is how you extend your agent's workflow. You can connect to anything. And we have in AWS Labs in GitHub, we have several MCP servers to connect to AWS services. You can create a diagram, you can create a cost analysis, you can create many things. Yeah.
So Walid, how this is useful in troubleshooting? Does that help us in troubleshooting if we have?
It helps, but basically there are tools. So if I check what tools are there, you can see that I have a diagram MCP server, so I can create diagrams of my architecture. I have kube control MCP server, so basically I can interact with any Kubernetes cluster. And I have Playwright. I can check online documentation, so like best practices, a good user guide, whatever. And of course, I have like reading from the file system. But what I want to do something dangerous, which is trust all tools.
Oh,
you shouldn't do this.
Don't do it in production.
Okay, most of the tools are read-only now. But if it writes, it's in your own risk. Okay? So let's say create a diagram to understand the architecture.
Nice.
Architecture of the examples. OK? While it's thinking, maybe you can do something else.
Would you like maybe switch to the slides?
Yeah, while it's thinking. It will take maybe a couple of minutes.
Yeah.
So basically, it has reasoning. And it's not just reasoning. It has follow-up. So it could reason wrong, by the way. But you can correct it, or it can correct itself. And it goes into a loop. Now, the problem with Gen AI is that, especially assisted Gen AI for development or operation, it can get into a dead loop. So you have a tool to clear the context. So sometimes, because of the context you gave, a wrong command or a wrong prompt, maybe it can go into a dead loop. So you have control over this.
All right. So
it's completed, by the way.
Really? I want to show them also the
OK,
themes.
show them first.
No, that's OK. If it's
no, show them
ready,
first.
if it's ready, it's OK. Let's show them.
I need to find the file. Where is it? OK. So it created a file. OK. Now, the beauty of this where is it, the file? Explorer.
I will give you some time to find the file while maybe I go through.
Where's the file again? Working. Here.
OK. Yeah. Temp. Open file in editor.
So you see the file?
Okay.
So basically, it went in the repo. It read the repo. It can give you cost analysis. It can do well-architected review of your architecture. And this file, by the way, you can see both. You can see the AWS infrastructure and icons. And you can see also the Kubernetes part of it. So the ones in blue are actually Kubernetes icons. You saw how simple my prompt was? So basically, my prompt was, say, create a diagram for what you see there. So it understood the document, created the architecture. Now I know what exactly is there. Maybe I can ask it to explain more, or maybe I can ask it for cost.
Amazing. OK. So, one thing I want to show you also before maybe we cover a little bit of the technical concepts on the slides. So one techniques we're using now, because we're running different types of workload, as I mentioned in the beginning, and how we control which type of workload run on which type of compute resources, whether at GPU or Inferentia, or even Graviton or normal Intel-based. So we're using taints and toleration. Let me show you the example for one of the deployment.
Remember, the goal is launch a workload, machine learning workload, and understand it better. So basically, using certain technology stack like user interfaces like Gradio, OpenWeb UI, and using actually Q, it can recommend to you. It can recommend to you what stack do you want to use, especially if you give it context. And you give it context using MCPs, model context protocols.
Yeah, so if we take like the GPU, for example, the GPU workload as an example. So as you can see here, this is a deployment manifest for our VLLM to run the DeepSeek. And as you can see, I put here taints to or toleration and the deployment to make sure this deployment will run on NVIDIA processors or NVIDIA GPU. And I did the same also on the node pool level. So if you check the node pools here, so again, in the node pool, I also have added a taints to make sure all nodes provisioned under this node pool will be taint with nvidia.com/GPU. So we play the same technique with GPU. We did the same also for Neuron to make sure that Whisper will run on Inferentia. So here we're adding again taint for Amazon.com/Neuron.
So basically, what problem he's trying to solve is that now I have GPU, I have accelerator, I have high-cost nodes. I don't want low-cost workloads to be assigned to them. So I want to make sure that it's only provisioned for the critical workloads that need accelerators. By the way, while he was running this and explaining to you, I ran 2 prompts, one for cost saving and one for recommendation of machine workflow. Do you want to switch?
Just before the prompt, I just want to show you one more thing here, because we are on the node pool. So also one very powerful approach here in EKS auto mode is now here I'm not defining a specific node groups or specific instances. I'm just giving it like I need to run on Neuron. I need to select any instance from Inferentia instance category. I want to mix between spot and on-demand to save on cost. So I will let EKS auto mode will decide for me. I just give it prerequisites or requirement I want to run my deployment, and then EKS auto mode will go and fetch the cheapest node out there in the region that match my requirement. And as our workload demand is changing over time, it will dynamically right-size the compute instances to make sure we're always optimized from capacity perspective and cost as well. So here, as you can see in the requirement, I'm just defining I need an instance from the Inferentia family. It will fetch whatever relevant at the moment from available at the moment from Inferentia, and I'm mixing between different capacity type, whether spot and on-demand. Now back to you, to Walid, to show us what interesting prompt he ran.
So basically, after the diagram that we made, I asked for another. Basically, it explains also the diagram, if you can see. And there are some example categories, like it's recommending ARM64 spot instance, where you can save up to 90% of the cost. GPU accelerated AI workloads. It's actually advising about VLM. VLLM is a serving library. It's a Python serving library. You can use it for one node, for distributed nodes. And it's picking up. The community is huge. And the Neuron, which is our Inferentia and Trainium. So I asked about how about cost optimization. So it gives me node provisioning optimization, the node pool. So it tells me like basically certain things I can do to the node pool. It can create actually any extra configuration. You don't need to create a node pool, by the way. EKS Auto Mode comes with the default node pool, but today, because it's ML, we need accelerators, we need GPUs, we need maybe Inferentia, maybe Trainium. These doesn't come by default, because if they come by default and somebody used them wrong, you will get a very good big bill. So it's recommending that we can use spot instance and right sizing. Yeah. How to do accelerator optimization instead of using the whole GPU. I can do time slice. So instead of saying 1, 4, I can actually time slice and share the workloads for a single node or a single GPU or whatever. Or other accelerators have other mechanisms for doing this. The storage class name, it's better to use GB3 for ABS. The networking is giving me some labels, and so on. So the other question I asked, I have fat fingers, that's why the other one open. The other question I asked was, well architected. And it answers me, and I ask also, where is my resources? So it runs AWS commands, it runs Kubernetes commands, and it finds out where my, did it find out? Didn't find out. OK. Because I don't have the credentials, actually, but it didn't find out. Go on.
All right. I think we have 1 minute left.
It depends, the other guy, yeah.
Yeah.
Any questions? Go to the QR code.
Yeah.
Sorry, I mean, this is our live coding exercise, and I don't really work well with business. I work well with developers. But if you have any questions, you want to know how to run ML workloads fast, usually when we do a customer call, it's 1 hour to 1 hour and a half for a proof of concept. What we were trying to show you that in 30 minutes, you can actually deploy. The challenge in deployment here will be the capacity. But the moment you diverse your compute, Trainium, Inferentia, Graviton, and use spot instance and on-demand instance, you have high probability of getting the demand. Because now it's not just cost, the challenge. The challenge worldwide is I need GPUs, I need accelerators. Can I get them? So that's the challenge.
I hope you had a chance to scan the QR codes on the screen. This is like a few resources to help you getting started, and similar repo for what we've built today.
Yes.
And finally, this is the QR code for feedback for the session.
Please give us feedback.
Your feedback is invaluable for us.
If
Please
the
give us your
feedback says
feedback.
Walid versus Ahmed, you know who to vote for.
Thank you very much for your time. Yeah, pleasure having you.
Thank you for your time, and thank you for being here.
Thank you. Enjoy the rest of the summit.